Kia ora koutou. Welcome to this next video of Science 1.1 Demonstrate Understanding of Aspects of Mechanics. Today we will be looking at speed time graphs. So in the past we've looked at distance time graphs, today we're going to be looking at speed time graphs. Speed time graphs are slightly, well, they're different to distance time graphs obviously, because on the y-axis it's showing speed instead of distance. And the effect that this has for the Science 1.1 course is that from these speed time graphs, we can be asked one of three things. We can be asked whether a line on the graph is showing constant speed, stationary, or acceleration for an object. We can be asked to calculate the acceleration of an object shown by the graph. And we can also be asked to calculate the distance traveled when we look at a graph like this. That's a very common question, the distance traveled one, and it's one that seems to be a common error or just a common thing that students forget how to do. So in this video, we'll be going through all three of those things. So if we have a graph like this, we could have an object, let's say we've got an object that is accelerating. So how would we show that an object is accelerating on a speed time graph? So if on this y-axis we've got 1, 2, 3, 4, 5. So this would, if there was a line across here, that would indicate that an object was traveling at 1 meter per second. This would be 2 meters per second and 3 meters per second. So let's say we have an object that is increasing its speed of 1 meter per second per second. So every second, the object increases its speed by 1 meter per second. And we'll do that until we get to 5 seconds. So that would look something like this. We would have we'll have a line that's showing an object that is increasing its speed. Just pretend that starts at 0. Up until from 0 meters per second for 5 seconds, it's increasing its speed by 1 meter per second. So if we see a line like this in a speed time graph, that is telling us that the object that is being described in this graph is accelerating. So if we remember back to our distance time graphs, this is slightly different to a distance time graph, isn't it? Because if a straight line is telling us that the object is accelerating, when we did our distance time graphs, acceleration was when we had a curved line, whereas a straight line just meant a constant speed. So for this graph here, if we see a straight line for a speed time graph, that's telling us that the object is accelerating. If we had an object, well, if we saw a line on the speed time graph that was just a horizontal line. So I'll draw a horizontal line. Let's say it stays at a horizontal for about 2 seconds. So for 2 seconds, this is just a horizontal line. What is that telling us about the object's motion when this line is going horizontal? Well, it's telling us that time is increasing, but the speed is staying the same. So what's another word for saying that the speed is staying the same over time? Well, that's saying that the object is traveling at a constant speed. So if we see a straight line, a horizontal line like this, in a speed time graph, assuming that the line is above 0, so if we had a horizontal line at 0 going across like that, that would be telling us that the speed that the object was traveling would be 0 meters per second over time, which is telling us that it would be stationary. So if we see a constant speed, if we see a horizontal line on a speed time graph, that's telling us that the object is traveling at a constant speed. Remember, this is different to a distance time graph, because a distance time graph, if we see the distance increasing at a constant rate, then that is describing an object traveling at a constant speed. So it's slightly, the speed time graph is different in that respect, in that a straight line describes an object traveling at a constant speed. So what if we then, from the edge of this point here, what if we draw a line that goes down to the 10 seconds, so it's going from 5 meters per second down to 0 meters per second, and that occurs from about 7 seconds here until 10 seconds. So for the remaining 3 seconds, for the last 3 seconds, the speed of the object goes from 5 meters per second to 0 meters per second. What is that describing? That would be deceleration. So this is a speed time graph. We've got a straight line, an increasing straight line shows an accelerating object. A horizontal line is an object traveling at a constant speed, and a line that is angled downwards is showing deceleration. So that's the first part, is to be able to use words to describe what the graph is showing. The next thing that we can do using these speed time graphs is to calculate the acceleration of an object. So the acceleration in these graphs is shown by the gradient, similar to the speed in a distance time graph is shown by the gradient. So remember, the gradient equals the rise over the run. Gradient equals the rise divided by run. So in this case, the rise is the speed and the run is the time. The rise here, the run here. So gradient equals the change in speed divided by the change in time. And that is the acceleration. So it's just the same formula as what we had used before. So acceleration equals the change in speed or velocity divided by change in time. So during these first 5 seconds here, what is the acceleration of this object? Well, what we'd need to do is find the change in the speed. So it's gone from 0 meters per second up to 5 meters per second. So the change in velocity equals 5. Got 5 meters per second as the change in velocity, and the time it's taken is 5 seconds. So the acceleration, quite simply, for this section, if we called it section A, the acceleration for this section is just 1 meter per second per second. So remember, to show acceleration, the units for acceleration, you need to go ms minus 2. For for this section of the graph, let's call this section, if this was section B, we'll call it section C. So what is the acceleration during this section? Well, we start at 5 meters per second and then we go down to 0. So for section A, it was the final minus the initial, so 5 minus 0. For this one, the initial is 5 meters per second and the final is 0, so we'd go 0 minus 5. So the change in speed for the next part of it, change in speed is negative 5. So the speed reduces by 5 meters per second, and the time that it takes for that to happen is 3 seconds. So to work out the acceleration for this part, we need to go negative 5 divided by 3, and we get negative 1.66, or we'll go 1.7, negative 1.7, rounding it up, meters per second, ms minus 2. Okay, so that's just a similar skill that we're using by calculating the gradient. When we have a speed time graph, we can calculate the acceleration. The third thing that we can do with these graphs is a different skill. It is calculating the distance that's been traveled by the object during this time. So to do that, to calculate the distance traveled by the object, we need to calculate the area under the graph. So distance traveled equals the area under the graph, or the line in the graph. So to work that out, we need to break this into triangles and rectangles. So we've already done that by labeling this section A, section B, and section C. Remember that the area of a triangle equals half base times height. So it's 0.5 times the base times the height. So in this case, we've got a triangle here. So we're going to go, the base is 5. So for A, we've got the base equals 5. So we're going to go 5 divided by 2. It's 0.5 times 5. 5 divided by 2, and then we're going to times that by the height, which in this case is 5 meters per second. So we're going to go 5 divided by 2 times 5. So 2.5 times 5 equals, so this is the distance, see, distance, that says distance, believe it or not, distance of area A is going to be 12.5 meters. We'll look at the distance of area B. So if we're wanting to calculate the area of a square or area of a rectangle, we need to work out, we go the base times the height. So the area of a rectangle is the base times the height. We don't do the half base like we would with the triangle. Base times height. So what is, if we're looking at the graph here, what is the base? The base is 7 minus 5. So it's important that when we're looking at the base in a graph, we are only taking the area for the section that we're looking at. So it would be easier, a common mistake would be to say that the base is 7, but no, the base in this case is 2, because it's 7 minus 2, and the height is still 5. So to find out the distance traveled for section B, equals 5 times 2. So we've got 10 meters. 10 meters for section B, and then section C, going half base again, so 3, half of 3 times the height, 5, so half of 3 is 1.5, so the distance traveled for this part of it would be 7.5. So C, I'm just going to write that down, equals, C equals 7.5 meters. And if we wanted to calculate the total distance traveled from this by this object, we would just add all of these values up. So we would go 12.5 plus 10 plus 7.5 plus 10 plus 7.5. So we'll end up with 12.5 plus 7.5 is 20 plus 10, 30. So the total distance traveled by this object in this in the area under this graph is 30 meters. So those are the three things that we can do when we're looking at speed time graphs. First of all, we can describe the motion of the object using acceleration, constant speed, or deceleration according to what's happening with the line. We can then calculate the acceleration of the object using the rise over the run, or change in velocity divided by change in time. And the third thing that we can do is calculate the distance traveled by the object by calculating the area underneath the graph. A common thing that gets confused is that people will look at the formula sheet and see that they'll try and rearrange this formula here. So just remember, if you're calculating the distance from a speed time graph, it's just the area under the graph. So either half base times height for triangles or base times height for rectangles. Thanks very much. I hope you enjoyed the video. Subscribe for more science videos, and I'll see you at the next video.